Hello everyone, welcome to Matrix. This is a circle-bound style game where two games are being played at the same time. On the left side of the screen, you will see Box Map, a map full of keys and locks where player A resides. On the right side is Maze Map, a map containing obstacles and a finish flag where player B is able to move. The goal of this game is to get player B to reach their flag, and to do so, we must rely on player A to move obstacles out of the way. Each time player A pushes a square box or a key into one of the hollowed squares on the map, which are locks, a different effect will be applied on the obstacles on the right. For instance, a key marked as 0, -1 will translate obstacles one space down along the y-axis. Later on in the game, you will also see triangle boxes appear in the box map, which rotate the entire maze map based on its corresponding matrix. Both types of movements can be seen under the keys functions text of each level. To launch this game, we begin by downloading the zip and unzipping it into a folder on your desktop. Open your terminal and use the cd command to navigate to the directory of your files. A detailed explanation of how to do this can be found in our README. Once navigated, enlarge the terminal window to be as large as possible, as our game will not run if the window is too small. Type in python3 main.py and press enter to start the game. The coding for this game was made possible using the curses library. We can begin by understanding how the level data is stored. As you can see, we have the files boxmap.txt and mazemap.txt in our unzip folder. These txts contain the layouts of each box map and maze map, as well as the initial positions of the players, flags, walls, obstacles, and locks, the latter two being denoted by N and L respectively. The text at the bottom of each level is also stored separately in a file called keyhint.txt. You may be wondering then how we store the boxes for each level. That can be found in the file called boxmessage.txt, which we decided to separate due to the large amount of data it contains. The first two parameters represent the position of the key, the third its color, and the fourth and fifth the effect it has on obstacles. The sixth parameter is reserved for the triangle boxes, determining how they will rotate in the maze map in later levels. Once the program starts, main.py reads all the data from these txt files and creates them according to the functions beginning with set, from set maze map all the way to set obstacles. Maps are stored in a list indexed by its level number. Scrolling further down, you will see the function runGame. The function runGame uses each level as a parameter and updates whenever the player restarts a level or is able to complete it. The first few lines initialize the level, creating the variables box game and maze game in reference to the two games being played. Then we see a while loop, which is how we're able to constantly read the user's inputs and update the two games in real time. Other commands such as S, Q, and R are also checked in this while loop for switching players, quitting the game, and restarting levels. That's cool and all, but then how do we turn the ASCII characters in the txt files into the colorful display you see when you run the game? For that, we have to go to game.py. The draw function here reads off the data from box message, as we initialize the shape and color of each box. Game.py is also how we check whether the player is in contact with any obstacles or finish flags. If the box which player A pushes into a lock is a square, the obstacles will move one step at a time according to the key function. If the obstacle meets player B during its movement, the death screen will be shown. If the box is a triangle, the maze map will rotate according to the matrix instead. The rotate function of the map, player, and obstacles are all called in the movebox function to update the maze map. Finally, map.py is how we handle rotations in our map. As you saw at the start of the video, some of our later levels will feature triangle boxes, which rotate the maze map. In map.py, we define the rotate function under the class map, which is also called back in movebox in game.py. So, that is pretty much how our code works. Some of our levels have multiple solutions, so try to be creative with your problem solving skills. Now, get ready to dust off your linear algebra as we dive right into the matrix box.